In this lesson, we're going to look at the relationship between circles and their tangent lines. Before we really get started, there's a couple things you're going to have to remember from geometry. We'll be using the Pythagorean theorem, and remember that's just a squared plus b squared equals c squared, and those are the sides of a right triangle. And then this fact will be really important for us. We're going to use this a lot. So the radius of a circle is perpendicular, that's what this symbol means, perpendicular to the circle's tangent line. And speaking of a tangent line, that's what this line is. Remember early in the year, we've looked at a secant line, which would just intersect this thing at two spots, but that's not particularly helpful for us, so this lesson will look at the tangent line. So we have some steps written out here for us to follow. Number one says to find the circle's equation, then we're going to use the slope between the circle's center and the given point on the circle, find the slope of the tangent line, and then finally use all that information to write the equation of the tangent line. But I'm actually going to walk you through that backwards so you can see why we need to do all these things. Okay, so if the goal is to write the equation of the tangent line, I know that would be like y equals mx plus b. So if I wanted to write an equation like this, I would need to know the slope and the y-intercept. So for instance, if I wanted to use the slope, we're going to use this fact that the radius of the circle is perpendicular to the tangent line. And I know that lines that are perpendicular have opposite reciprocal slopes. So if I want to find this line's slope, I might need to back up and just find the slope of this radius first. Okay, so what would I need to know in order to find the slope of this radius? I would need to know like these two endpoints. So this one happens to be the center of the circle, and then this one's on the outside of the circle. So those 2 points are going to be really important. And that's why we have to find the circle's equation as basically the first step in this process. Because we need to know what the center is, and we need to know what the other point is on the outside of the circle where we're finding the tangent line. So this problem is pretty easy because we have a picture to look at. But just to follow the same process all the time, let's write the equation of the circle. In this case, it's centered at 0, 0, so it's just x squared plus y squared. But then on the right side, let's see, the radius here is 5, so this would be 25. Now the other important piece that we needed to find was this other point on the circle. That'll usually be given to you, or maybe like the x value is given, you have to plug it in. But in this case, again, we have a picture to look at. So if you just follow this x value down from the x-axis and over to the y-axis here, you can see the point is 3, negative 4. So now we have the equation of the circle and these 2 points. Let's use them to find the slope of this radius. So remember, slope is rise over run. So from the center point to this point on the circle, the rise is, well, we're actually going down. So it's negative 4, and the run is over 3. So the slope of the radius would be negative 4/3. All right, now the next step is to find the slope of the tangent line. That's getting us closer to what we're actually looking for. And that's easy to do if you just remember that it's perpendicular to the radius. So perpendicular lines have opposite reciprocal slopes. So the reciprocal would be 3/4, and since this one was negative, the opposite means this one's going to be positive. And we're really close now. Now that we have the slope of this tangent line, all we need is to figure out the y-intercept. And actually the way I'm going to do that is I'm going to plug in the slope that I know, and then this point x comma y that I'm going to get right here. So if you really want to get fancy, you can call that the point of tangency. It's just the point where the tangent line and the circle meet. But again, in this case, that was the point 3, negative 4. So that's the x and the y value that I'm going to plug in. And remember, m was 3/4. So just plugging all that into y equals mx plus b, it would be negative 4 equals, and then the slope was 3/4 times the x value is 3, plus the b value, which I don't know yet. All right, so 3 times 3/4 is 9/4. I still have plus b, and negative 4 on the left. Now I just have to subtract 9/4 from both sides. So I'm actually going to think of this negative 4 as negative 16/4. I'm just going to switch it to a fraction so that I can subtract 9/4 from it. And that actually gives me negative 25/4. So that's the b value. So we're finally ready to write the equation of the line. It's y equals 3/4 x, and the b value is negative 25/4. And if you take 25 and divide it by 4, it's a little bit more than 6, or in this case negative 6. And that makes sense because that's exactly where the y-intercept is. So let's try a couple more examples. Alright, so now it says write the equation of the line tangent to the circle, x minus 5 squared plus y plus 3 squared equals 289. And the point that we're looking at is 20, 5. So we don't have to do any work to find the equation of the circle. It's already given to us. But it's good to know the center and the radius. So remember, the center would be the opposite of these numbers, so it's going to be positive 5, negative 3. So just remember that the equation of a circle is x minus h squared and y minus k squared. So since these signs are opposite, that's why we have positive 5 and negative 3. And the radius over here is the square root of 289, which is 17. So this just helps me get a handle of like what the circle's like. So it's at 5, negative 3, maybe it's over here, and the radius is 17, so it's a pretty big circle. And we're looking at the point 20, 5, so that's probably like here. This is terribly not to scale at all. But we could label this 20, 5, and the center was 5, -3. So this helps me get an idea of how to find the slope of this radius. So I'd look at the rise over run, and the rise needs to get us from -3 up to 5 for the y value, so that means we'd have to go up 8. And the run, we're going from 5 over to 20, so that means we have to go over 15. So like I said, this is not to scale at all. But now I can see that the slope of the radius is 8 over 15. And this tangent line is perpendicular to the radius, so its slope is going to be the opposite reciprocal of this. So the slope of the tangent line would be negative. I can see it's going down to the right, and it would be 15 over 8. So again, I have everything I need now. I've got this point x comma y, which is on the tangent line, and I have its slope is -15/8. So I'm just going to plug everything into y equals mx plus b. So the y value is 5. The slope was -15 over 8. The x value from that point on the line was 20. And I'm solving this for b. So I'll leave the 5 where it's at. And then let's see, I can simplify 8 and 20. I could divide both of those by 4, so that would be 2, and that would be 5. 5 times 15 is 75, so -75 over 2. So we got plus b. So now I just have to add 75 halves to both sides. So if you think of 5, like how many halves is that? So like what over 2 would be 5? Well, that would be 10 over 2. So if I take 10 halves and I add 75 halves, that would be 85 halves. And that's the b value. So there we go. The equation of the line would be y equals, the slope we had was -15 over 8, and the y-intercept is 85 halves. So it's not a particularly pretty answer, but it was pretty easy to do. We just have one more example, but this one's going to require us to do a little bit more work because the equation of the circle they gave us isn't in standard form, so we don't know much about the circle yet. And they didn't even give us the point, they just said x equals 4. So we'll have to practice what we learned in the last lesson, which was completing the square to write this in standard form. So remember, we start by just kind of like setting this up for ourselves. So I'm going to get the x squared plus 2x together, the y squared plus 4y together, and then just move the 164 over to the other side. All right, so now I can take x plus half of that b value down here, so that would be plus 1, and then y plus half of this b value would be 2. But now I have to go back and fix the equation because 1 squared would be plus 1 that we didn't have up there, and 2 squared would be 4, and we didn't have that. So now I've got to add 5 to the other side, because 1 plus 4 is 5. So that gets me 169, and then keep a plus sign in the middle over here. So I can see the center of the circle is going to be -1, -2. Again, make sure the signs are opposite. And the radius is whatever the square root of 169 is, which is 13. Again, I just like to get a visual of what's going on. So at -1, -2, the circle would be like right here. And with a radius of 13, again, that's pretty big. So it would be kind of like this. So the center is the point -1, -2. And they just said that the x value is 4. They didn't tell us what the point is on the circle. And so you can kind of imagine x equals 4 would be right around there. And there's actually 2 points on the circle where x equals 4. So let's see why that is. So I'm trying to find the y value on the circle where the x value is 4. So I'm going to use the equation of the circle, and I'm going to plug in 4 for the x value. And I'm actually going to use this one because there's just one spot to plug in x, so it'll just be a little bit easier than using this equation from above. So that would look like 4 plus 1 squared plus, and then keep the y plus 2 squared, and everything else in the equation, so the equals 169 as well. All right, so 4 plus 1 is 5, 5 squared is 25. So I've got 25 plus this stuff equals 169. So I'll subtract that over to the other side, and I get 144. And that's nice because that's a perfect square. So now if I try to get rid of this square, I'd square root both sides, and I get y plus 2 equals, okay, and now here you got to be careful. When you take the square root, you get two answers. You get plus or minus, in this case 12. And that's why we have 2 spots on the circle where x equals 4. One of the most common mistakes I see is people will say, oh, plus or minus 12 minus 2, so that would be plus or minus 10. It doesn't work that way, right? You got to think of this in 2 cases. So positive 12 minus 2 would be 10. Or if you had negative 12 and you subtracted 2, that would be negative 14. And that kind of makes sense because the circle isn't centered at the origin, so like this point isn't going to be quite as high as this point is low. So at this point in the problem, I suppose we can just pick one of these points and then find the tangent line to it. So I'm just going to pick the point up here. So that must be the point 4, comma, and then the y value, the positive y value I picked was positive 10. All right, now we finally got the problem set up so we can start finding more of the information we need. So like the rise over run, like I want to find the slope of this radius because that's perpendicular to the tangent line. So from the center, well, the y value there is negative 2. Here the y value is 10. So I'd have to go up 2 and then 10 more. That means this is plus 12. And the x values are going from negative 1 to 4, so that means I'd have to go right 5. So the slope is 12 over 5. But remember, that's not the actual slope I'm looking for. That's perpendicular to the tangent line slope. So the opposite reciprocal of this would be negative 5/12. So now I know the slope of this line, and I have this point on the line, 4, 10. So I'll use that for x and y, and remember, plug everything into y equals mx plus b. So the y value I'm plugging in is 10. The m value we found is negative 5 over 12. The x value I'm plugging in is 4, and I don't know b. Alright, so I can simplify the 4 and the 12. If I divide both of those by 4, that goes away, and that becomes 3. So now I have negative 5/3. So 10 equals negative 5/3 plus b, and now I just have to add 5/3 over to the other side. So remember, think of this as like how many thirds. That would be 30 thirds, and I'm going to add 5/3 over there, so that would be 35 thirds. That's the b value. Alright, so the equation then would be y equals negative 5/12 x plus 35 thirds. Again, it didn't end up being the prettiest answer, but as long as you follow the steps, you'll always be able to find the equation of the tangent line.